Solve this problem for us here. Anyone know the answer? You want to come up and show it? You want to come up and show it? Yeah, come on. Who knows the answer, do you think? Raise your hand if you think you know. That's pretty good.
Just one straight line?
Yeah. So I like this one because it makes you think, you know, you get stuck in numbers and symbols and all of a sudden you're breaking those boundaries there, right? You're making that symbol into a number. And I say, I used to always just have this here, but then you guys were all too clever and you would do like that, or I don't even know which way it goes, like that, you know. That's too easy. Okay. So last time, we started talking about some of the nuances of inheritance, and in particular, we looked at abstract base classes, which, even though it has the word abstract in its name, I think remains a little bit of an abstract concept for most of you until you start seeing it kind of in practice a little bit more. So the main thing with an abstract base class is that it's labeled as an abstract class. It contains abstract methods that are labeled as such. Those have to be implemented in any classes that derive from this class. You can't make an instance of this class because it has unimplemented methods. Because you can't make an instance, you also can't make instance variables because there's nothing that's going to hold those instance variables, right? You can have some static instance variables or static variables, but not instance variables. And basically the idea is it provides a contract for the interface of other derived classes. So let's just look at the code again for that. Remind ourselves a little bit what's going on. So we decided shape should be an abstract base class. That's because shape is a useful organizing tool, but it doesn't actually have properties of its own, right? We don't know what its area is. We don't know what its perimeter is. We don't know what numbers you have to hold to make a shape. So this is a generic idea. And we think all shapes should have an area or perimeter. And again, you could have other things you want to have with shapes, colors or whatever you want. And we are providing this toString method that works for all derived classes. And again, the key to making it work in some ways is that we're not accessing instance variables, the raw form of them. We're using the getters that are guaranteed to be part of the derived classes. And so when a derived class calls a toString and inherits this, calls the get area, and the get area is called on the derived class method instead. So when a rectangle asks for the toString, it gets the area, this code. And when a circle asks for toString, it gets the area call here. Okay, so again, it's sort of a way of figuring out where responsibility for some of these actions occur, or they happen in sort of the general area or in the specific area.
When we're so on this one, you don't have override on the get area, but on the rectangle you do.
Yeah, I mean, it's just, it's.
So my question is, when we're pulling inheritance from an abstract class, we still need to use override, even though the.
So you never have to use override, well, but you should use override.
Right. That's what I'm
saying. And if I said here, again, if I said get areas, it's going to complain and say, you think you're overriding something. Well, it's actually complaining more that it's. I'm not overriding. I'm not implementing the get area that I need, but there's another problem here that I think I'm overriding something and I'm not. If I don't have that, again, I'm using my own organizational skills, which are limited, to remember that I am overriding this method, and there's no warning if I do a typo or something like that I get it wrong. So override is just there to help you keep consistent between the superclass and the derived classes when you're inheriting something. So the problem here is all of a sudden, we got multiple files, and you're sort of tracking stuff in different locations. What's provided here, what's demanded here, what's provided here, what am I implementing here, and life has gotten a little more complicated, right? And so that's sort of the reality of it. When you're working on a bigger project, you need structure to make sure things work out okay, and part of your skills are to kind of absorb this enormous mass of structure into your brain. And to be honest, this is part of why you always hear about people getting in the zone, coding. Getting in the zone sometimes means you're staying up all night. That's the sort of nice way of saying it, right? You're in the zone. No, you're really actually just like working all night on this thing. And part of the reasons for that, I think it's very difficult to make progress on complicated projects until your brain has sort of brought into working memory all these nuances about what's going on. And so you have to kind of keep mucking around with it until somehow you're able to understand the structure of all these different parts. And it's hard. We're only good at holding a few things in our head at the same time. So in computer science, we try all these little tricks to kind of help that process along. We use named methods. We don't have to remember the code inside those methods. We sort of assume we know what's going on in there. But we still have to kind of get this big complex structure in your brain and see how it all fits together. And sometimes it's painstaking debugging and printing and watching it run and just sort of seeing what's going on. It just takes time to do that. And then you check social media, you get a phone call, you watch a cute video, and that all just gets flushed out of your brain, and you start all over again. So one hint maybe for working a little bit is making sure when you're working on this stuff, try to get in a position where you can concentrate and kind of get in the zone. Makes it sound cool, right? Oh yeah. Okay, so this kind of abstract class is like a halfway thing, right? This one is sort of funny. There are these things that aren't implemented, that are these abstract methods, and then there's things that are implemented that are inherited in the derived classes. And so it's sort of like it's halfway between a real class and not. So we can take this one step further and make what's called a pure abstract class. Let's see. So let me see what I want to do here. Okay, so in a pure abstract class, which what we'd call an interface, I no longer call this an abstract class. I actually call it an interface. All right, and you have these. You don't have to say abstract here anymore. It's assumed. In fact, you don't even have to say public. Why would that be true? And then you can't have any implemented methods. All right, so an interface is just a bunch of abstract methods. Okay, so there's no implementation whatsoever in an interface. Now that even seems like a dumber idea than an abstract base class, right? It doesn't do anything for you. So this purely is an organizational tool, and it doesn't have any code for it. Now if I want to have my derived classes use this, oh boy. Okay. I don't say extends anymore, I say implements. Implement shape. So basically, I'm the implementation for these things promised in the shape interface here. Okay? And in this case, I am implementing get area, and I'm implementing get perimeter. And that seems fine. And same thing with circle. I am going to implement shape. And I implement area, and I implement perimeter. I have my own toString, that's fine. And so if I run this, does it work? Okay, so I ran it. I made a circle object. I printed it out. I returned the super toString. This toString actually comes, so all classes. So here we have our shape class. And circle implements it. It's not really a full inheritance, but I implement it. Shape, even though it's not shown, inherits from object. Well, let's see. from something, extend something, you can only extend from one other class. All right? You can only pick one to be your super class. You can implement a comma-separated sequence of interfaces. So I can implement shape, comma, collision detector, comma, drawable, comma, sprite, comma, all these different things. And as long as I implement each of the methods that those promise, then I've satisfied the contract by implementing that thing. So we will see examples of where we start grabbing promised functionality and implementing it pretty soon. But the basic idea is when you implement it, you don't get any code for free, you get organization for free. Okay? Now, why do we want to do this really? So there's some sort of organizational stuff. But it's more like we want objects to play together well in our code. So and this was the idea of what's called polymorphism. And it's derived from Greek. Poly means many, morph means form. So basically it's something to do with like many forms of something. And here we're talking about many forms of an algorithm or many forms of code. It basically means there's something in the language that can do different behaviors depending on what kind of thing it really is. We've seen a little bit of this polymorphism idea. So for example, what does plus do besides turn into a 4 occasionally? What does plus do? It adds two numbers. So what else does it do? Yeah, so if I have dj plus I, that turns into dj high, right? That is a different behavior than this behavior. So it's the same symbol, it has many forms, right? It can act as addition, it can act as concatenation. So that's one kind of polymorphism. When we talk about generics, that's actually a form of polymorphism. So an array list can hold integers. It can also hold strings, right? So an array list is not a thing that just does one thing. It has different forms. So that's a kind of polymorphism as well. Now, in the context of inheritance, we talk about subtype polymorphism. And that's the part I want to talk about today. And that's where derived types can have different behaviors than the superclass. And we've seen that in our shapes, because circles have a get area, and rectangles have get area, and they have different meanings, right? I mean, they both compute an area, but the way they do it is different. So, the way in Java this basically works is a pretty simple idea. A Java reference, so basically, we talk about as variable names that are object types or really references to objects, can reference a class of its own type or a subclass of that class. So for example, we're used to seeing like a circle, C equals new circle 2, and this circle reference can reference something, an object of its own class, and that's pretty straightforward. That's what we're used to seeing. If circle inherits from shape, then we can, or square inherits from shape, then we can assign a new square to a shaped reference. All right, so this is a more general kind of reference, but it can point to the derived classes for it. And in fact, we know that, again, object is sort of the top of all this inheritance chain. It's the most general one. And so an object can also reference a new circle or a new square or whatever you want. So this object reference O can reference a whole bunch of different kinds of types. And that gives us a lot of power for doing different things. So, for example, let's say we make an array list of shapes. Okay? Our array list of shapes can hold a new square. You can also add a new circle to it. So our array list all of a sudden is not just holding one kind of thing. Instead of an array list circle or array list square, we're holding all kinds of shapes, circle, squares, whatever inherit from that shape superclass. And it's smart enough to know when you say, hey, tell me the area of this square, it computes it for the square, not for the shape, which doesn't really exist anyway, right? So let's try this out, first of all. And to do this, I think I'm going to first go back to our basic abstract class. So I want to add some stuff to it. Extend shape. Extend shape. All right, so we have now our abstract class shape. It requires a get area, get perimeter, and it has a toString that's implemented. And down in circle, let's make first an array list of circle equals new array list circle, and I'm going to add, oops, I keep doing this because I add this, you have to add that second part, the generic type to it. I forget the variable name when I do that. So C array. Okay. And I need to import ArrayList. All right, so you should have seen ArrayList in lab yesterday. If you missed lab, this is going to be a little confusing, but ArrayLists are good things, and you should use them a lot. Raw Java arrays are sort of comfortable at this point, but they don't have all the power of an array list, and there's no good real reason to not use an array list. An array list is a little bit slower than a Java array, but you're not doing anything yet that depends on that, so don't make that some sort of macho, I want to be faster kind of thing here. So let's use our C array, and we're going to add a circle to it. And then I'm going to, kind of like I was doing here, get index 0, that object, and I'm going to call its to, well, I'm just going to print it. So all right, so this is not a polymorphic thing, right? This is an array list of circles. There are no derived classes from circle, so all we can hold in this array list are circles, and I just want to make sure we can get that much done. All right, so I have added a circle to the array list, and I've printed it out, and all looks good. Now let's make an array list of shape array equals a new array list of shape with shape. And now I'm going to add to the S array C1, and I'm going to print out that item S array, and it should have the same behavior. So this is the circle array printing out its area, and this is the shape array. Now let's force this a little bit harder. So we have our rectangles. So rectangle R1 equals new rectangle with a height and a width. And I'm going to add R1. I don't know what it's trying to get me to do there. To the shape array. And then I'm going to print out that item. And if I run it, so it prints out, this is for the circle that's in the array of shapes, and this is for the rectangle that's in the array of shapes. Now, you should be going, woohoo, that's awesome! And I know you're not really feeling it, right? The reason this is awesome is, like, imagine like a bigger structure. You have a game, and it's filled with, archers and giants and wizards and all these things. And how are you going to have nice code? You don't want to have 4 different array lists, one for how many wizards are in your game, and how many archers are in your game, and how many giants are in your game, right? Because every time you add a new kind of character, you got to add a new code that handles that particular character. Instead, if they all inherit from enemy and implement proper common things from enemy, then they can all be in one array list. And your game code now says, for all enemies in enemy, you know, move them, shoot them, defense them, help them, you know, blah, blah, blah. And you have this beautiful, nice, tight loop. Your code is very easy to understand, and organization is like easy to add to for other people. So this kind of thing comes up a lot where you really want to have arrays, lists of things that are not all identical, but have some common organizing structure. And this is the way to do it, through this base class. Okay. Now let's go back up here and just show you that we can't, I'll do it down here because the rectangle is defined. So if I have my circle array and I want to add R1, stop. It's going to complain and say, add circle, the arbitrary circle cannot handle a rectangle. Right? So trying to make this of a lower level derived class kind of array doesn't get this kind of polymorphic behavior that allows multiple things to coexist in the same space. Okay. Questions about the sort of basic idea here before we start explaining a little bit more? Yeah.
So if we wanted to be able to carry anything, we would just make our related list an object array list?
Yeah,
it
so
would accept any object that we created?
If I make that object, then everything inherits from objects. Well, okay. Object. And this all works, and in fact, this works now, right? Because R1 is an object.
Well, no, you changed the S array, now this is an array.
Oh, I changed the S array, yeah. I thought I was up further. Yeah, well, that's not going to prove anything. Hey, can whoever's talking over there not talk, please? I can't quite pick out who's doing it, but give me a break, right? All right. So, yeah, now there are places, so you might say, why should I ever make an array list of anything besides object, right? Because I can handle anything. Because at a certain point, you want to know what behaviors are guaranteed for objects in this list. And if I make it shaped, then I'm supposed to be able to guarantee that they all have a get area and get perimeter on there. And so if I go over all the elements of that list and want to get the area and perimeter, then I can kind of guarantee that that's there. You can't guarantee anything if it's just all object, right? Now you can kind of assume it's there and get in some trouble. All right. Okay, so as we start doing more complicated programs, we're going to see more inheritance from existing classes because we want to steal their functionality. Essentially, we want to use their functionality. The other way to do that, of course, is through the implements, where we're actually implementing some portion of stuff and we want to participate in some larger ecosystem. Now I want to talk for a second about how this works in Java. So again, when we make a variable, an object variable, it is, in my mind, super important to keep in mind exactly what's going on here. So, for example, that first one, we have O is a reference to some object that was made, which is a circle. It knows it's a circle. And it has its own data like radius inside it, right? Radius 1. The C circle also references a circle, and it has a radius 2. All right, so again, these things are not the objects directly, they are references to objects. Now, from the polymorphic point of view, if you want to start saying what is a circle, well, it is something that it knows it's a circle. It actually also, inside there, has a reference to the circle class with whatever methods are in there. And there's not like a separate copy of all the code for each object here, right? So somewhere there's a circle class. It has methods. It implements these things. the code for it is like actual numbers and stuff that can get run. And so when you make one of these objects, it also says, hey, I'm one of these things as well, right? You ask me for my toString, and there's a toString method in there, that's where it finds it, right? So these things floating around the system. Now, a circle is also a shape. So it also references the shape class. Well, actually, it inherits from shape. So first of all, it has a shape object. And it might have some of its own values in there. And then shape knows as part of the shape, my planning was poor here. It knows as part of the shape class, and so it knows about the shape methods. All right, so it gets kind of complicated, right? These things are all floating around memory, and they all kind of reference each other. Let me try going to a pre-made picture where there's some hope of it coming across. So if I make a new circle of type shape, so it thinks it's referencing a shape. It's really pointing to an object that's a class circle and has some values in it. But it also references a shape. And when you try to use these different methods, what happens is at compile time, it goes through and says, hey, does shape have an area method that's defined? All right, so in order for a shape reference to use an area, it checks at compile time to see whether shape has an area or not. It doesn't have to be implemented, it just has to be either an abstract method or an implemented method, okay? So that's how it decides whether this is a legal thing for you to do when you're writing the code. Then when you're running it, and you actually call shape S area, it says, okay, I'm pointing to this circle object. Circle objects have an area code, and I'm going to call that area. All right? So it first gives precedence to any area that is in the actual class that the object belongs to, not the type that it's declared as. So if I override area, let's say area actually existed in shape, this one gets precedence. And that's what, when we override, we get that value for that particular, more specific thing first. If area did not exist here, then it would keep looking and say, okay, nothing in class circle. Hey, I'm also a shape because I inherit from shape. Do you have an area? And it says, yes, I have an area here. All right. So I'd say the interesting thing here is that even though this thinks the compiler, when it compiles that it's a shape, because it was assigned a circle object, it works on the circle object methods by following these references around and getting the area that's appropriate for a circle here and not for a shape. So really, the only thing you really have to know about this is when you call a method, it calls it on the object type that it really is, not on what you sort of say the generic type is above it.
So what is the difference between calling it an object versus a circle or versus a shape? Is it what you can allow to do with it? Like, say you make an array list of circles, you can't put a shape or an object in there, but...
So why would you ever want to make this a shape here? Is that kind of the question, right?
Yeah.
Like, because you can't really get to this shape kind of stuff because of that, right? But what you can do, oops, I wanted to stay here. What you can do, for example, let's say I made a add area method in the shape class. And you pass in two shapes. And that could be a circle and a rectangle, or two rectangles, or two circles, or whatever. But inside this code, I'd be like using the getArea method. And so even though this shape thing seems very general, it will use the getArea for the circle and give its actual area. And all of a sudden, I can do cool things like I don't have to write code to specifically add a circle and a circle, and a circle and a rectangle, and a rectangle and a circle, and a rectangle and a rectangle, and a rectangle and a square. I don't have to make all the code that handles all these possible combinations. I can make this sort of generic kind of thing that adds together two shapes, and they ask them, if you're a circle, give me your area. If you're a rectangle, give me your area. They provide their areas, you add the area together, and you get the proper answer there.
We'll have to declare them as a shape rather than a circle or rectangle.
Well, if you declare that as circle and rectangle, then it could only add together a circle and a rectangle, right? If you declare it a shape and a shape, you can add together whatever combinations of derived types you can imagine.
So I guess my question would be, if I create it as a circle and then try and pass it to that method, it will say, no, I can only take...
It'd be okay, because a shaped reference can handle that passed object that is a circle. So let's try that, I guess. Okay, let's make an add area. Let's see, abstract class shape, and let's see, I want to make a public static, return double, I guess. Add area of a shape S1 and a shape S2, and I want to return S1 get area plus S2 get area, and that's it, right? Nothing complicated there. And so now in circle, where all my stuff is hanging out, I can say double added area equals a shape dot add area. So it's a static method. I have to get it through the class name, right? So shape dot add area. And I'm going to pass in C1 and R1. And I'm going to print out the added area. If I run this. No. Convert for ArrayList. Oh, this is back to some whatever I was up here. I never quite cleaned up from that. All right, shape. Okay, so added area is those two things added together. Looks about right. So, here I've made something very general here, right? I can do any combinations of stuff that I want here. It's all legal because these objects, so this, when you call a method, right, the object that is, this reference gets passed to this reference here, right? So they're referencing the same object. And because this is a more general thing than a circle, it can handle that reference.
So if it knows the R1 is a shape and it knows the C1 is a shape, in our code when we're declaring those two variables, what circumstance would we want to start it as a shape versus a rectangle versus a circle in our...
I would say it's rare to, for example, here,
right there, yeah. Why would we
make that shape? That would be unusual.
So we don't. That's typically not.
That's typically not done.
Okay.
But when you're trying to make like parameters of methods, there is an advantage to making that as general as possible,
right? Because
then it can handle combinations of these different kinds of things.
So the example where you showed we declared an object O that was a circle, we probably would never do that.
Not in this particular form, but it's really not. Parameter really is the exact same thing, right? Yeah. Good question. Okay, so it gets confusing now. All of a sudden you see this like, I'm adding shape and shape, and in your mind, that's saying I'm adding two shapes, but really you can add circles and squares and rectangles and all those things underneath it. And so the complexity here again gets what's going on is a little trickier, all right? And you have to be careful about what's going on here. Now, I want to show one. Any more questions about that? I mean, you got to try it out a few times for sure to get a handle of it. But you make an abstract. And also, this doesn't have to be an abstract class. Okay, it could be just a normal class that you inherit from. It's still a superclass. So it's nothing to do with the abstraction or interfaces or things like that. It just has to do with whether you inherit from it or not. Typically, when you start making these kinds of trees of inheritance, that one that's up high is going to be some sort of abstract class because that's the way, like why would you make, let's say you're making a game and again you have like a giant and an archer and a wizard. Which one of those would be the top class? The wizard or the giant or the archer, right? None of them, right? Just some sort of enemy thing. So there's usually some generality that you have to think about that becomes the superclass. Now, I want to show one other little thing about using the implements. So an interface, again, is a purely non-implemented class, and you can have a bunch of those attached to your class. And so I'm going to implement something here. We've seen on strings the compare to. All right, what does compare to do? You used it a couple times now. It's kind of a funny method, I think, right? Because we're used to saying like dot equals, and it says you whether it's true or false that it's dot equals. What does compare to do instead? It kind of tells you if it's if it's bigger or smaller or equal, right? And it does that by giving some value back that's either 0 or -1 or +1. And so that makes me, I don't know, that's what makes me feel weird about compare to, because I want true or false, and then instead you're saying, compare these two things. It's -1. I'm like, I don't know what that means, right? But, so this is a useful thing though. Like if you, for example, if you want to call sort on an array, and it has a compare to, then it can sort itself because it knows how to compare these two different kinds of objects, whether it's bigger or smaller. And so compare to comes from a class that is an interface. So it's not really a class. It comes from an interface. And it basically says, if you implement this thing, then you can participate in this larger world of compare to kind of things, like sorting and other kind of things. So in order to do this, you have to implement comparable. And comparable is a generic class. So we have to give it the type we want to compare. And in this case, what are we going to be comparing? Shape. Right? This is kind of weird. And of course, this is also kind of like the assignment, if you're struggling with this part of it at all. Right? So we have a class, and we're extending something, and maybe shape was generic as well. Anyway, it can get complicated, right? But in this case, comparable says, I want to be able to compare two shapes. And by saying it at this level, we're really comparing also circles and rectangles and all those subclasses, because that's the kind of benefit we get from having this base class here. Now, to implement comparable, we're going to override from the comparable generic shape class. Oops. Override public. What does comparable return? An int. This mysterious int. And it is inside this class is the compare to method that we have to override. And compare to compares, normally you have like a string compared to some other string, right? That's the form of it, and it says compare this object with this object. So compare to is going to have a single parameter coming in, which is the other object we're comparing to. And in this case, that is a shape, right? Now, what should we compare with these shape objects? Like, how do you decide if one's bigger than another? What should we use? Yeah, it's area. You could use a perimeter. Maybe that's what you care about. If you're like trying to figure out like road lengths along a coastline or something, maybe you want to look at the perimeter of that coastline or something rather than the area. But in general, maybe area seems like a pretty reasonable choice. So I can say if get area is equal to other dot get area, then we're going to return 0 because they're equal, and compared to return 0 when they're equal. Else if get area is bigger than other get area, we're going to return 1 in this case. So we're basically saying that myself is bigger than you, and I think the rule is that it returns 1 then. And else return -1. So it's either equal or it's bigger, and then the final case is that it's smaller, and you don't have to have the if statement because the only way you can get here is if it's smaller. And so I'm going to return a -1 here. And basically, when you're doing a compare to, you're deciding, how these objects should be compared. It's not necessarily, if there's a bunch of different instance variables in there, you have to make some decision about how to decide whether one's bigger than the other, right? It's not necessarily always clear. I could have collapsed this down a little bit. So what am I really comparing? What kind of thing am I comparing here? What are these? What is this get area thing? Is it a string? It's a double, right? So I could actually this get area. I can kind of leverage that, and I can say I can use the compare to that already is implemented on doubles, and kind of assume in some ways they know what they're doing down there. So I'm not going to try to figure out this sort of complicated if else kind of thing, and say, hey, these two shapes are compared by their area. Let's let the area compare themselves to each other, and then they can decide whether that's the right answer or not. Now I had to hack this a little bit because these things are returning lowercase doubles, primitives, right? Compare to lives on objects, capital double. So this is actually taking the lowercase double here and boxing it through that weird box process into an uppercase double. And then I'm calling compare to on this uppercase double code to make that work out. All right, so even though this looks nice and concise, there's actually a whole lot of stuff going on here. And again, I don't really like in Java it has this sort of magic turning primitives into objects for you, because I think it hides a little bit too much of what's going on here, and it makes me a little uncomfortable. All right, so I would say that this is a preferable answer to this answer. For example, when I was looking online to remind myself how compare to works, the code there that was published that I was going to steal from said this, right? It was wrong. And so I would have propagated that answer and switched around the value of -1 and 1 in my own code, because I was using Stack Overflow and not looking very carefully at it, right? But if I go on this way, then I'm assuming if it's in double, that's official Java, right? And they know what they're doing, and we can count on that one to be correct.
When we implement the comparable class, does that mean that we have to use all of its, override all of its methods, or are we able to just do the one method?
I think that is the only method in there.
Okay.
So normally when you implement an interface, right, you have to actually implement everything, because otherwise you're not a full participant in that ecosystem. But in this case, that is not such a grand challenge. There's only this one thing in there. Okay. Now I can use this. Let's compare two things. It's not that dramatic, but we can say system out C1 compare to R1. And again, because we implemented this in shape, not in circle, I can do this kind of cross-object comparison in a very natural fashion, right? So it gives me a lot more power than implementing a compare to in circle for circle, circle, a compare to for circle, rectangle, compare to square, rectangle, right? The combinations just get out of control. And it's all the same code, essentially. So we can take advantage of that and put it up in shape and see what happens. And so if I run this, C1 compared to R1, it is bigger because C1's area was this 300 thing, and R1 was 8. All right, so that worked out for us there. All right, so I would look over this stuff, the posted code. These are, I think, difficult concepts. We see people when I teach 35.5 that are still not good at understanding what's going on here. And it would be really great if you were good at it. So I want you to kind of look this over and try to understand not only how it works, but why we want to do this. And again, it's hard to show it in 10 lines of code why you want to get a big structure going, but it helps organize your code. All right. that's enough, I think. So, see ya Friday.